We're in section 3.9, page 26. The example on here says water pours into a conical tank at a radius 4 feet and height of 10 feet at a rate of 10 feet cubed per minute. Part A says when the water level is at 5 feet, how fast is the water level rising? I also want you guys to notice that they do give you a diagram in this one. Most of the time they do not, and you'd have to draw your own. So we do have 10 feet cubed per minute. This is our dV dt. So we know that dV dt is equal to 10 feet cubed per minute. And it wants us to know when the water level's at 5 feet, so when the height's at 5 feet, how fast is the water level rising? So they want us to find dH dt. So it's talking about how fast, again, that's a rate, when h is equal to 5 feet. So we need to use a formula for a cone. We've done this already. I'm going to go ahead and write that down again. If you don't know the formula, you look it up on the exam. They will be given to you guys. So it's volume equals 1/3 pi r squared h. But the previous one we did, I think the height was fixed, and so we had a constant value in there. This time the height is not fixed. That is changing as that water is rising. So the first thing is, taking a derivative of this, you'll notice that you're going to have dr dt's and dh dt's and dv dt's. So we know dv dt. We're looking for dh dt, and we don't know anything about dr dt. So I need to rewrite this formula with only h's and no r's in it because that's an unknown. It's too much stuff that I don't know. So it's set up already over here for you guys. It says by similar triangles. Similar triangles happens a lot when we have too many unknowns, and we can replace one of those unknowns by using some kind of ratio. Usually it's something along the ideas of similar triangles or a trig formula. So if I were to solve this, you can cross multiply any way that you want, but if you can get r by itself, you'll get 2/5 h. So what we're going to do is we're going to take this value and substitute it in up here for our r value. So I'm going to go ahead and zoom in, fill this in. So we have volume equals 1/3 pi, and instead of r, I'm going to substitute it in 2/5 h squared times h. Cleaning this up, we get 4/75 pi h cubed. And then from here, I'm going to go ahead and take a derivative with respect to time on both sides. So I'm going to have dV dt is equal to, multiplying that 3 out in front, we're going to have 12/75 pi h squared times dH dt. And you can simplify this. Fraction out in front, and we'll have dV dt is equal to 4/25 pi h squared dH dt. From here, I'm going to go ahead and substitute in all the values that we know. We had already written down that dH dt is equal to 10. Again, I'm going to leave those units off for right now. 4/25 pi h, our height was at 5 feet, so go ahead and substitute in 5, and we are looking for dH dt. So going ahead and solving for dH dt to isolate that, we're going to end up with, it's going to be 25 times 10, all divided by 25 times pi times 4. And simplifying this, we get dH dt is equal to, so our 25s would reduce out, and then 10 over 4 is going to become 5 over 2 pi. And our units for this is height, and the height is feet. That's how we're measuring them, per, and our time is in seconds. The problem does continue down below. There is a part B. Part B says, as time passes, what happens to the rate of which the water level rises? And explain. So I'm going to go ahead and copy down the formula that we had from up above for dV dt. And I'm going to leave h as a variable and dH dt also as a variable. So we had 4 over 25 pi h squared dH dt. And then solving this for dH dt, we are going to have 25 over 4 pi h squared times dV dt, just moving around those variables. And so the question says, as time passes, what happens to the rate at which the water level is rising? Let me explain. So as your height increases, so as h increases, what happens to the rate? Well, since this is a denominator value, our h is in the denominator, so as the value in the denominator gets larger, this implies that our dH dt is going to decrease.